Hello, ninth graders! This is Teacher Raquel San Juan of Urdaneta City National High School. Welcome to our virtual instruction for Quarter 3, Week 7 of Mathematics 9. The most essential learning competency for this week is proves the conditions for similarity of triangles. So our topic for this week will focus on triangle similarity. Let us begin by discussing the characteristics of similar triangles. Just like the similar shapes that we discussed last week, similar triangles have vertices that correspond to each other. So in this figure here, there is a one-to-one correspondence between the vertices of triangle ABC and triangle DEF. A corresponds to D, B corresponds to E, and C corresponds to F. For the second characteristic of similar triangles have corresponding angles that are congruent. As you can see from our example here, the three angles of triangle ABC are congruent to the three angles of triangle DEF. So we have three pairs of corresponding angles that have the same measure. For the third characteristic, similar triangles have corresponding sides that are proportional. Okay, if we form the ratio between the corresponding sides, we will have the proportion AB over DE equals BC over EF equals AC over DF. Now replacing these ratios with the measures from the given, we have 6 over 12 is equal to 5 over 10 equals to 4 over 8. And you will notice these three ratios are all equal to 1/2, so that means they are really forming a proportion. Next, I will explain the different postulate and theorems on triangle similarity. In here, we only have to show the relation of certain parts of two triangles for us to conclude that those two triangles are similar. First, we have the Aaa Similarity Postulate. If the three angles of a triangle are congruent to three angles of another triangle, then the two triangles are similar. So here, you only need to show that the two triangles have three pairs of corresponding angles that have the same measure, just like triangle LMN and triangle PQR. Measures of L and P are the same. M and Q are both 50 degrees, and angle N and angle R are both 77 degrees. Therefore, triangle LMN is similar to triangle PQR by Aaa similarity. Next is the Aaa Similarity Theorem. Two triangles are similar if two angles of one triangle are congruent to two angles of another triangle. Unlike the Aaa Similarity Postulate, here we only need to show two pairs of congruent angles. We can already say that the two triangles are similar. So like in this example, triangle DEF and triangle RST contains two pairs of corresponding angles that are congruent. Therefore, triangle DEF is similar to triangle RST by the Aaa Similarity Theorem. For SSS Similarity Theorem, two triangles are similar if the corresponding sides of the two triangles are in proportion. So in here, we don't need the measure of the angles of the triangle to establish that the two triangles are similar. We only need the measure of the sides. Alright, so what we will do here is to check if the ratio between the corresponding sides are in proportion. So if we form the ratio between the corresponding sides of triangle ABC and triangle DEF, we have 10 over 15, 8 over 12, and 6 over 9. Now, if you reduce these three ratios, they are all equal to 2/3. So that means the corresponding sides are proportional. Therefore, triangle ABC is similar to triangle DEF. Next is the Sas Similarity Theorem. If the corresponding sides of two triangles are proportional and the included angles of the sides are congruent, then the two triangles are similar. Here, we are going to check on two things. The first one is check if the ratio between the corresponding sides of the two triangles are equal. Okay, the ratio between the corresponding sides xy and st and then zy over ut is 4/8 equal to 7/14. Now you will notice these two ratios are equivalent to 1/2. Therefore, we can say that the corresponding sides are proportional. The second thing is to check if the angle between these corresponding sides are congruent. And as you can see, the measure of angle Y and angle T are both equal to 80 degrees. Now we can conclude that triangle XYZ is similar to triangle STU by the Sas Similarity Theorem. In the triangle angle bisector theorem, if a segment bisects an angle of a triangle, then it divides the opposite side into segment proportional to the other side. Okay, let's look at this example here. We have triangle UTV and the angle bisector TW. This angle bisector TW divides angle UTV into two congruent angles. So we have UTW is congruent to VTW. Now this angle bisector also cuts this opposite side into parts which are proportional to the other two sides of the triangle. So if you check the ratio between UW and VW and UT and TV, it's going to be the same. 6/4 is the same as 12/8 because they're both equivalent to 3/2. The triangle proportionality theorem states that if a line parallel to one side of a triangle intersects the other two sides, then it divides those sides proportionally. Okay, we have here triangle ABC, which contains segment XY, and this is parallel to side CB. Now this line segment here cuts the other two sides of triangle ABC into proportional segments. Meaning, if you check the ratio between AX and XC and compare that with the ratio between AY and YB, they are going to form a proportion because 12/8 and 9/6 is equivalent to 3/2. So that means these parts here are proportional segments. Last but not the least is the right triangle similarity theorem. If the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. In our example, we have the right triangle MER. The right angle is at MER. MR is the hypotenuse and this is the altitude. We have segment EY. Now the segment EY divides the original right triangle MER into two similar right triangles. So we have triangle EYR and triangle MYE. Now this the biggest triangle, MER, is going to be similar to triangle EYR and triangle MYE. So those are the important ideas that you have to remember about similar triangles. Thank you for listening and paying attention. I hope to see you again on the second part of our virtual instruction for week 7. Bye!